We ready to go? Good deal. All right, so my name's Jim Nitterauer. I am from AppRiver. How many of you heard of AppRiver? One person, two people. Okay, well that's good. Everybody knows about AppRiver after we get out of here. All right, so how did I get here? Last year I came to NolaCon. First, I want to thank Rob and his team for putting this together. It's a really great event, so be sure and thank him when you get a chance. So I was here last year, and unfortunately I said some really big words and acted like I knew what I was talking about, and suddenly I'm here talking, so it's what happens sometimes. And realistically, I've been with AppRiver since 2006. I'm a senior systems administrator there, responsible for network deployments in 11 data centers globally. We take care of network security and network operations. Our two main services are SecureSurf and SecureTide. One is a spam and virus filtering service. The other is a DNS malware filtering service. Both of them are global. We filter messages for about 850,000 email boxes on a regular basis. When I checked, in fact, I can't show you my Graylog Live demos today because we're overwhelmed with spam to the tune of about 600,000 messages per minute going to our spam quarantine. So we can thank the virus writers for that today. But in any case, I'll do my best to show you some of the live stuff or some of the backlog stuff. I have a degree in microbiology and biochemistry from the University of Alabama. I saw somebody with an Alabama hat. I guess he stepped out, roll tide. And I've gotten into IT and trying to speak more at some of these conferences. This week I'm working on my CISSP certification, so I should have that shortly. So today, what I'm going to do today is lay out what was my challenge when I came to AppRiver. How did that lead me to looking at some of the legacy log analysis tools that are out there in the market. I want to go over some of the new kids on the block, some of the new applications and services that are out there for managing log data. I'm going to put some of those pieces together to show you how I devised a solution to solve some of the problems that I had. We're going to look at some of the common DNS exploits that we dealt with. Now keep in mind we're focusing here on an open DNS resolver, so think Google 8.8.8.8 or OpenDNS. Similar to that, I'm going to show you some real world examples of how we uncovered some of those attacks. So, start with the basics. I came to AppRiver. We had just had a rollout of our SecureSurf service that failed. I wasn't on that team, wasn't involved in that. We worked with McAfee and Trusted Source on that. It didn't work out too well for us, so we decided to roll our own. Problem was the guys on our networking team did not know how to secure DNS. We had to have open resolvers that anybody could use because our customers, they travel, they go to coffee shops, do whatever. They need to be able to access our DNS. So my goal was I had to have an open DNS resolver, it had to be resilient, had to be globally redundant, had to be fast, like Google fast, and it had to be quick to secure and enhance if we came across any problems. So, an aside, I had this thrown in my lap thinking of it brought to mind a story. So we're in New Orleans. I figured I'd tell you a little story about a company that's not too far from here, the Tabasco Company. They're located in Avery Island. They're a little bit to the west of New Orleans. Their main product for many, many years was just Tabasco sauce, only one kind of sauce. In the late 90s, early 2000s, they started to run into some marketing issues. Their market share went away because just like craft beer, craft hot sauces came out on the market and their market share dropped. CEO of the company spent all kinds of money, did all kinds of market surveys, hired consultants, did all of this stuff to try and figure out how to increase his market share. Couldn't figure it out for the life of him. One day, a factory worker walks up, knocks on the door. Mr. CEO, I have a good idea for you. Anybody want to know what that idea is? Anybody guess? He says, sir, why don't you just make the hole in the bottle a little bit bigger? People still make 4 or 5 shakes on their omelet, on their sandwich, whatever. We'll sell more hot sauce and your problem's solved. So the moral of the story is with difficult problems, there's usually a simple solution. So that was what I was kind of applying when I went through thinking, how can I solve this problem with DNS? And I started with the logs. I figured if we can see what's going on, not so much at the DNS level, at the application level, but at the network level, we would be able to protect our environment. So in our system, obviously you have logs. You can log event logs, system logs on your Linux boxes. You can turn on Microsoft AD DNS log. Log data is pretty much everywhere. The problem is when you need the logs, it's usually you're under fire, there's an emergency, right? Everybody's calling, hey, the internet's down, it's not working, you're trying to figure out what's going on in your logs. Well, your log data is just data, it's just rows and rows of information that doesn't make any sense. So the problem with log data is the log analysis tools are pretty limited. There's a lot of good ones out there that you can use to aggregate your logs. You can use Kiwi. That used to be an open source solution that was bought by SolarWinds. So if you ever get any marketing information or sign up for any of SolarWinds free products, be prepared to turn on your spam filter because they will spam the hell out of you. You could use syslog-ng, you could use any of these other things. PRTG also ingests syslog data and will present it in a web interface for you. The problem with all of this data is it's just syslog data, right? It's rows of information in syslog format. It really doesn't give you too much ability to query and create reports from that data to see what's going on, that give you information that really matters. The other problem with some of these is they're either cheap, they're free, or they're really expensive. We contacted Splunk a few years ago to see what they would charge us to do just a portion of our logging, and it was to the tune of $50,000 or $60,000 a month. So we quickly and politely said, no thanks. So a lot of these tools, sorry about that, a lot of these tools vary in complexity. A lot of them have different support levels. A lot of them are either very easy to use and don't give you much information, or they're very complex and require a lot of training to make them work. Common denominator is they lack flexibility, right? So if you want to be able to get the information out, you got to be able to adjust how that information is presented. And these logging solutions now don't really present that kind of information. So what we did is we looked at some different ways to process logs and kind of broke it up into bits and pieces. And one of the things that came out at the same time that we were looking at all this was the Elk stack, right? This was just getting started. So that includes Kibana and Logstash and Elasticsearch and a few other components. And that's a good foundation. That's kind of what we built our solution around, but we changed it up a little bit. What we decided to do is figure out how to gather our log data from incoming queries for our DNS requests. So, and aside, the way our network works is we have globally distributed DNS servers around the world. All of those VIPs have basically the same IP address, just like Google, different IP address. All of the requests come in and we log those requests at the network layer. So we're able to see who's making requests in real time. The other thing we do is we actually log AD DNS logs from the internal side, so we can compare those two, and I'll show you how we do that later. The one problem we ran into is how do we format that data, right? We don't want just syslog data because it's pretty meaningless and it's pretty hard to mine if you've looked at it. It takes a whole lot of time to deal with. So what we ended up doing is we ended up shipping these logs in real time. And I will tell you, we use F5 load balancers on our front end, so we were able to use TCL to write some iRules that would take this data and distribute it, and Graylog has the ability to do remote log, or not Graylog, F5 has the ability to do remote logging, so we were able to ship those logs to a central log ingestion cluster. And the other thing we wanted to do is be able to index and visualize the data. So gathering logs, there wasn't anything magical about us gathering these logs. We knew where the data was, we knew what format it was in. The problem was we needed to convert it from the format that it was saved into something that we could use. Well, Graylog, I don't know how many of you are familiar with it, but it has a formatting capability that you can use that's called GELF. I'm going to go over what that is here in a little bit. So the formatting of your logs can be done at multiple locations in the chain of where you're collecting this information. The data can be formatted as you write it out to disk, wherever you're storing your logs. It can be formatted as you're shipping the logs, so you can read existing log data, change the format, and ship it that way. Or you can ship the log data and ingest it on the input side and format it before it's indexed in your indexing solution. In this case, it would be Elasticsearch. So we decided and tested this GELF log shipping packet. And if you look at what is GELF, it's not a GNOME similar to a Smurf. It's a method for shipping log data in a JSON packet. So this is really interesting because it has, you can use it and send it directly to REST APIs and ingest that data that way if you want to, or you can send it to Graylog or any other input system that will take in that data in that format. The nice thing is GELF has several fields that are defined by the standard that are built into the JSON packet. And the nice thing is then you can go and you can add into that your own fields. So you can devise and make your log data fit the format for the data that you want to mine later on. Nice, and there's also a bunch of GELF programming libraries for just about any language that's out there. So how do we get those logs I'm getting a little feedback over here. How do we get those logs from our log source to our log input? Well, on our servers that are basically Windows or Linux servers, we use NXlog. There's a community edition, there's a paid edition. The free edition works very well. It's basically a log router. You point it to the directory where your log files are, it will tail those logs in real time, grab those logs, and then send them to some remote location. And the nice thing is it has some built-in formatting capabilities. You can use Logstash, that's part of the Elk stack. That works really well. Also, it's a little bit too much for what we use on our Windows side of things, so we just decided to stick with NXlog. We also use the F5 remote logging capabilities. We apply filters when we ship those logs out. So next piece of the puzzle, Graylog just released version 2. It has a very cool feature that it just added, and I'm going to go over the whole feature set for Graylog again. I'm just kind of bits and pieces of this together so we can see how I put together pieces to make a whole solution. But what they added to it was something called the Graylog sidecar. So imagine if you have thousands of servers with NXlog or whatever running on those servers. You don't want to have to touch every one of those servers every time you want to add logs or change logs, make a change to how those logs are formatted or shipped. So what this sidecar does, it installs on all those end servers, and it then interacts with whatever log shipping tool you're using, whether it's NXlog or Logstash. But the nice thing is it allows you then to manage all of those remote endpoints through one panel, through one web interface, through the Graylog web interface. It's a very cool solution. So the latest version of Graylog, and what Graylog is a collector. Basically all it is, it consists of a web server, it consists of collector endpoints, and it consists of a way to send the data to indexing. The nice thing about it is it will actually accumulate your logs, put them in a journal file. Think of the journal as a cache. So what happened to us today is our Elasticsearch cluster couldn't keep up, so the journal files built up. The log data is there, but it'll take some time to peel off and get sent to our Elasticsearch cluster. You can also use Graylog to ingest log data and then forward an exact copy of that log data somewhere else if you already have other log solutions in place. So you're not limiting yourself as to what you can do. Think of it as an inline log analysis tool. It uses Elasticsearch in the back end for its database and for indexing the data, and it keeps all of its configurations in a MongoDB database. So the other thing Graylog 2 has now is the ability to archive. As your logs build up, you can take your logs and archive the ones you don't want, and I'll show you a little bit about this in a minute. It gives you the ability to monitor and alert, so you can set streams, you can filter incoming data, tag it with a stream, and then alert when certain incidents happen. Let's say you could use it for example, we use it for logins to Linux servers, right? Somebody's trying to brute force log in a Linux server. If they log in more than 3 times, it'll be tagged in a stream and alert and send us an email saying, hey, this Linux server had 3 logins with this username within this period of time, and that's a problem. It gives you the ability to do drill down analytics, which I'll go over in a little bit. And it integrates directly with your Active Directory or LDAP server. So if you have an Active Directory domain, you can set permissions in Graylog using that Active Directory domain. And the other cool thing that they often don't talk about and is overlooked is the ability to create custom Java plugins. So remember I said you can format your data when you write it to disk, you can format your data when you ship it from your endpoint, or you can format your data when you ingest it into Graylog. That is done through writing Java plugins. Those Java plugins create an input, they ingest the data, they take the format of that data and format it into a Guelph packet that's then injected into your Elasticsearch so later you can go and look at that data. And we're going to look at an example of that here in a minute. So Elasticsearch is the indexing backend for Graylog. Right now it's at version 2.3.2. I think the one that they're working on for beta is 5. Don't ask me how they go from 2.3.2 to 5, but that's their deal, not mine. One thing I will tell you, if you use Graylog 1, version 1, you have to use Elasticsearch version 1, whatever, version 1.7 I think was the latest. If you're going to Graylog 2, you can use Elasticsearch version 2. They are not interchangeable. So if you do have a Graylog cluster up and working and you want to upgrade, you're going to have to upgrade Graylog and your Elasticsearch at the same time. So Elasticsearch is basically a clustered indexing. You can put as many nodes out there as you want. It's very fast. It's very redundant. It is kind of a pain to get set up, but once you get it set up, it works very well. The nice thing about ingesting your data with Graylog is you can then go and use the Graylog web interface and use its functionality to do log analysis. And you can also use those same indexes from Elasticsearch to, for example, use Kibana and create more customized dashboards to look into that data in real time. And it's the same set of data. You're not duplicating your data in any way. So both of these support a simple query format. I'm going to give you some examples of this later on. You can create dashboards and save those dashboards. Those dashboards can be displayed on screens. They update in real time. You can set filtering on different streams. You can do a whole bunch of different things that you would never be able to do with some of the older logging tools. So how did we use this? What we ended up looking at, the biggest problem we had were DNS amplification attacks. Everybody know what these are? No? Okay, I'll go over them very quickly. So if you want to take somebody down, DDoS your neighbor, figure out what their IP address is, start sending DNS packets out to a bunch of queries, a bunch of open DNS servers, but spoof the IP and put their IP address in it. So you can use about a megabit of bandwidth and send a small query, usually about 50 kilobytes, to a DNS server. Except you ask that DNS server for an any query, a text query, an RRSig record. So that ends up coming back maximum size 4096 bytes. If you look at the ratio, you're getting an amplification of up to 80 times on that data. So a 1 meg internet connection can DDoS somebody at 80 megs, right? So now imagine 10,000 servers doing that to your buddy next door or to Microsoft. This happened to Microsoft a year and a half ago, right when they were about to release the Xbox. And then it also happened to another well-known publication that made an announcement last year. They decided that they were going to, what's the word shall I say, pare down the amount of exposure of their models in their magazine. The next day, they were DDoSed for about 8 hours in the afternoon. Anybody that had Ultra DNS that day was out of luck. They couldn't use any of their services. So in our case, because we're an open DNS resolver, we become the middleman in these kinds of attacks. So people will use specific domain names. They'll hit our server, spoof the target IP, and try and have us send data back to them. So we would end up participating in those. The problem with those is they come in at the rate of, they could be 100,000 a second, right? So they eat up our resources, and they also cause other people to start blocking us. And when I get through here, what we ended up doing is we ended up figuring out how to create some dashboards, and I can't show you this, can't see it real well on the screen, but I'll bring up the live web interface for it. And we're able to tag through searches queries that are coming in from all of our endpoint VIPs. And the minute that somebody starts trying to do any queries, text queries, any of those large queries that shouldn't be happening, we see them because they're anomalies, right? They're happening at a frequency that's way greater than what they should be happening normally. And then we're able to go on the back end through some other tricks that we have through iRules on the F5, add a block for a particular domain, let's say, that they're using in these attacks, and our DNS VIPs just drop it and ignore that traffic without impacting anybody else's traffic. And the fortunate thing is most of these attacks are done using domains that nobody would ever want to go to anyway, and there's no reason to have 1,000 any queries coming up every second. You will see some sites on the internet that use any queries as a cheap way of testing DNS, like DNS Stuff and some of those other places. They'll do an any query against your authoritative server and then parse that out on their side. But we don't care about that. If they want to do it that way, that's fine. The other thing that we see, which is kind of interesting, this is a really big deal. Malware can use DNS to exfiltrate data from your infected machines. This is how it works. So the nefarious person registers a domain. This is one of them here, this ps780.com. They infect the machine with malware. The malware starts then pulling data from wherever it wants to get it, from the disk, memory, wherever, and it creates, through some algorithm, a long string, and it starts appending pieces of that string as a subdomain to the DNS query. It sends that query out over the internet. Does your firewall block it? Does your DNS server block it? Does your DNS server care? Right? It just sends that data out, right? You said data go out over the network. When it gets to the authoritative server, it answers, hey, here's the IP address. But it also takes that data, it knows how that data was encrypted, and it starts accumulating that data on the other side. So if you see these kinds of things happening on a network, your network's infected and somebody's taking data out of your network, we can guarantee that 100%. We don't know the algorithms that they use to put the data into those subdomains, but we do see it on infected machines. Once we clean the machines, we're able to see the problems go away. So this is data exfiltration through DNS. The other things that we're able to see are botnet command and control calls. When machines are infected, and one of the big ones, if you have browser plugins, it's called epic-unit-scan.info. If you see that DNS query on your network anywhere, you have an infected machine, one or more on your networks, and you need to get it off of there. That's just one of many, but this is an example I'm using. That particular botnet domain is a rental. You can go find it. You can rent time on that botnet network. It's a browser plugin that's installed into Chrome. I think there's one for Firefox, and I know there's one for Internet Explorer and Edge. It installs. Somebody rents time on that botnet network. That thing just sits there, and every time the browser opens, every hour it phones home, looks for a new command. If a new DNS command comes in with a certain packet on it, it activates that botnet command and control inside the plugin. The plugin goes to some remote site, downloads malware, and affects that machine. Okay? So if you see these kinds of things on your network, you need to stop them before they become activated. And we're able to see this because our SecureServe product has, because we filter so many email messages, we're able to see every URL in those email messages, and we're able to analyze those URLs for malicious content. So we'll activate those URLs, go out there and see what they do, see what the payload is, analyze that, and if the payload is bad, then we'll put that domain into a block in our DNS, and we'll generate what's called a CTN, or a critical threat notification, to our customers. They'll get that, and then we'll be able to work with them to analyze which machines on their network are compromised. So some other things that you can figure out from looking at your DNS logs, and I'm going to go into some examples here, I hope, in a few minutes. You can find out whether your DNS cache is poisoned. Now, we haven't gone to this step yet, but basically what you would have to do in this case is log DNS query responses from your DNS cache servers, look at those and compare them to known values, right? And anything that would flag as a value that was outside of what it should be, you could look at that and say somebody's trying to poison my DNS cache. Another big one now is DNS lockup. This is new. Many DNS servers are realizing that they cannot take any queries, right? So a way to prevent any queries is when a query comes in on UDP and it's an any query, you can set your DNS server to tell it, I'm not going to answer on UDP. Ask me again on TCP, okay? So you should have port 53 TCP open if you're going to allow any queries. So the remote DNS server will then ask on port 53. Well, the bad guys have figured out that if I ask on port 53, I can create these half-open connections to the DNS server through port 53 on TCP, and if they open enough of those connections, they'll just shut down the DNS server. That's called DNS lockup. You can look at DNS hijacking because you can actually see outbound DNS requests to see whether they're going to the right location. And I will tell you that if you are forwarding DNS requests to your ISP, you're not doing what you need to do. If you have an AD server or any cache server on your network, where should you forward it? Anybody want to guess? The root servers. The root servers and the root servers only, right? Never trust your ISP, never trust an upstream company unless it's a security company like us, OpenDNS, Google, somebody that's well known that you can trust. You can't trust your ISP's DNS server. You don't know who else is on that, so you need to make sure that you're sending your queries from your servers to the root or to a known good source. One of the other things that you can grab in DNS logs is you can look at domain bit flipping. Several years ago, there was a good talk at DEF CON that talked about bit flipping. Memory, when it's heated up, bits can change in memory before stuff is written to disk, and you can get changes in files that will change the DNS lookups, will change some certain things in your DNS lookup, so you can see those Another thing we see also are these domain generation algorithms. Malware tries to hide in normal traffic. So a nefarious piece of software may just start making DNS lookups for tons of random domains, but somewhere dropped in those random domains is the one bad domain, right? So it's trying to hide itself in all of these DNS lookups. And if you have enough data, you can look at DNS lookups and figure out which domains are the nefarious ones in this noise of background data. Other things that we use this for, Graylog, is device logins. We can check all of our routers, everything else. We can see when people log in, when they log out, how many times they attempt. The possibilities of what you can use this kind of logging for are pretty wide open. So now I want to see if I can get our environment to come up here, and I'll show you a few samples of what we look at. And I don't know if this is going to come up here without me sharing the screen. The screen sharing is not working quite right on this computer. Let's see. I'll put it on second screen only, and we'll see what we get. Okay. So I can't see it here, so I'm going to have to move around to where I can actually see it. So what you're looking at here is Graylog interface in real time. It's actually pulling in data, real-time data. And you can see right now, I'm going to come down there and point out a couple things. So I hope I don't get feedback here by walking in front of the speaker. So what's happening?
Hi folks, Iron Geek here. Unfortunately, we had a few video problems, so we have no audio up until about the 29-minute, 30-second mark. Sorry for the inconvenience.
Nothing I can do about it. The Elasticsearch cluster just didn't keep up. But that's what we have used it for. I know I didn't give you really a whole lot of detail, but hopefully with a little bit of creative thinking, you can start to use this in ways that will help your network. one of the problems, one of the things we talked about in a class this week, the CISSP class, is if somebody compromises your machine and your logs are all on that machine, what's the last thing they're going to do? They're going to cover their tracks, right? So if your logs are not being shipped in real time from those machines to something like this, how do you know what happened, right? You have no integrity of your data. You don't know what happened. So this kind of solution can be really, really powerful for a multitude of things. It's not just looking at DNS traffic. Okay, but it does give you some insight into how we used it to solve a few problems on our side. So, any other questions? I know I'm a little bit early, but yes, sir.
Have you had any success with detecting deepening malware, like every minute, every 10 minutes, hours, stuff like that?
Yes, when we know the domain name, if we search it, we can see the peaks, like that Epic Unit scan. It does it exactly every hour from customers, so I can filter by their IP that's infected. I can see every hour the 4 or 5 requests where it's phoning back home. Without the domain name, you would have to, not really, because you'd have to know what you're looking for, right? Because in this logs every DNS request that hits our public VIPs, right? So if we created a stream and flagged that particular input, or you can use regex in this in your streams, right? So you can find a particular pattern that matches and then flag that as a stream, and then if a certain threshold's met, that stream will send you an email, okay? You can do that sort of thing with it. I don't know if I'm answering your question 100%. Any other question? Yes, sir.
Do you manage clients' email exchanges as well? Given that, like, you can tie your SPF record to their DNS, so that's another data point for you, right?
Yeah, for our customers, we host their email. We manage their MX records for them, so they don't have to worry about that. We just tell them what to set them to, and then they're managed behind the scenes, so we can rotate them around to any server in our cluster without them knowing it.
So do you play around with, like, for example, the reporting side of who's trying to email on their behalf, and then you kind of get that?
We haven't done that yet because the email volume is 10,000 times higher than this. so we haven't built the infrastructure out to do that. That's our next phase. That's what we're working on right now. So that when somebody calls our support for email, we can go through and use Graylog, and it analyzes all the email across all of our incoming servers. And we say, oh, we saw this email from so-and-so to your domain at such and such a time, and it's lightning fast. It's just a matter of how much hardware you throw at it to make it work. We just haven't grown it enough yet to do that. But based on today, I would blow this thing up in 5 minutes with the amount of email that we get. Any other questions? So I'll be around later. I appreciate your time. I know we're a little bit early, but I'd rather be a little early than go over. So thank you for your time. Thanks for coming out.